Assalamu alaikum warahmatullahi wabarakatuh. Hello, everyone. So today we're going to discuss what a sliding window algorithm is. And we're also going to solve an easy problem on Leetcode for a sliding windows to better understand the implementation in Python and how to use it and when to use it. So for this lecture, I'm going to keep it very simple, not to get into too many details of time complexity or space complexity, just to understand this very fun concept. So what sliding window is basically it is a sliding window. Okay, so to keep it simple, it's used for searching mostly in linear data structures. Okay, what do I mean by that? Now you have, for example, a string. You have a string, right? And the string has letters X, Y, Z, Z, A, Z. And I want to find out specific characters. Let's say if I had a string which was A, B, B, A, C, B, A, B. And I wanted to find out how many times in this string does the pattern B, B, A occur, or the pattern B, A occurs, right? Now, with just looking at it, we can tell that BA only appears twice. But when it comes to writing an algorithm, we need to understand how the data structure works. We need to follow the rules of the data structure. So for a string, since we all know that for a string, you have indices, and you can slice the string by their indices in Python or in any other language. For example, if this was a string is equal to S. If I wanted to get the A, B, B, the way I would slice it would be take the indices, use a column, and define a range. So I would take from 0 to the index 2, and that would give me A, B, and B. And I could keep continue doing that until I find the right pattern or the whole string. But basically, the sliding window is used for looking for patterns, finding specific patterns, and running and executing operations based upon the patterns. So how does it work? The implementation can be very easy to very complex. You can have a fixed sliding window, or you can have a dynamic sliding window where the implementation can be way more complex depending on the type of data you're dealing with and type of question, type of problem you're trying to solve. So here, to better understand it, I will take a question from Leetcode, and we try to understand by implementing it. So I'll try to solve this question again, since I've already solved it. So we have a question here that says, we need to find substrings of size 3 with distinct characters. Now that's a lot of information packed into a single phrase, single sentence. So how about we go ahead and read the question. A string is good if there are no repeated characters. According to this question, we're looking for a good string that has no repeated characters, which means if I have in the string X, Y, Z, I do not want it to be X, X, Y, Z, or X, Y, Y, or I don't want any of the characters in the substring being repeated. Now, what is a substring? Let's understand what a substring is, right? Since it's mentioned here, substrings, we need to find substrings. We do not need to find strings. We already have a string. We need to find substrings. So a substring will be basically, if you have a string X, Y, Z, Z, A, Z, a substring can be just X, A substring can be the whole string. String is a substring of itself, just like in mathematics, a set is a superset of itself. Or it can be XYZ, it can be XYZZAZ, it can be XYZZ, YZZAZ, or anything that can fall under the string will be a substring. It can be one, or it can be the whole string, or it can be anything in between. Okay, so that's what we need to understand about the substring. So we are trying to find a substring that has non-repeated characters, right? And the question is going to ask us, given a string S, return the number of good substrings. What is a good substring? A substring is good if there are no repeated characters. So we need to find the good substrings that have no repeating characters, substrings that have the length 3, which means in this case, if X, Y, Z, Z, A, Z is our example, the length should be 3. The length of the substring should be 3, which means we can only have 3 characters at one time to call it a substring. The next step is to find out if the substring is good. When is a substring good? A substring is good when there are no repeating characters, when the X does not appear twice, when the Y does not appear twice or thrice, when the Z does not appear twice or thrice. Okay, and our length is fixed if we call our length K is equal to 3. So we need to find substrings with a length 3 that are good, which means they have no repeating characters. So the way we're going to go about it is we're going to see, does in X, Y, Z with length 3, do we have repeating characters? No. So we have at least one good substring, right? We have at least one good substring. In Y, Z, Z, we have Z appearing twice. We move on. We don't count it as good substring. Z, Z, A, we have Z appearing twice. So we skip that. Z, A, Z, and now our string has ended and we cannot extend any further because we need to keep it officially 3. So Z, A, Z, no, we have Z appearing twice. So we're going to skip that. So we have only one good substring in this case. All right. So that's how we're going to find it, but we cannot slice it every time. So instead, what we do, we use a sliding window. Instead of slicing it every time and writing for 1,000 characters, a string with 1,000 length of 1,000, we cannot create 1,000 operations. It will be not doable. So instead, what we do, we use something called a sliding window. A sliding window is basically fixing a length. Is a constant sliding window will be fixing a length of your search. So for example, if you wanted to search, you can search by iterating, but then by using a window, you can encompass multiple elements. So in case of X, Y, Z, Z, A, Z, how we'll use a sliding window is you will set its length 3 and put the window over it. And then you slide the window all the way to the end. And how it's going to slide is, that every time you have checked for good substring, you contract the window from here and contract the window from here and expand the window from here. So it will be YZZ this time. Let me try to explain it one more time. Wasn't a good diagram, I admit it. X, Y, Z, Z, A, Z. I want to slide a window of length 3. A window is going to be a slice. A window can be one character. Well, we're not going to keep it one character because if we want to check only one character, we could have just looped over. But the smallest window I can have is at least 2 characters. So I'll check 2 characters at the same time. Let's say if I want to check if the length of my search is 2, I would check for 2. So the next iteration, it will be Y and Z. The next iteration will be Z and Z. Next iteration will be Z and A, right? So basically what I'm doing here is I'm sliding my window, right? And then A and Z. But this time, what I want to do is I want to check substring of length 3. So I'll keep my search to 3 characters, X, Y, Z. Okay, let's go ahead and remove that. Next will be Y, Z, Z. Next will be Z, Z, A. And the next will be Z, A, Z. So my window slid from XYZ down to ZAZ, and my search is done. Okay, but programmatically, how are we going to do it? Well, what we're going to do is we are going to use pointers. So whenever we loop over a string, we usually use an iterator I. So what I'm going to do is imagine the string has its memory space. Each character has its own memory space, right? So my I, if I say for I in range length of the string, which is this string right here, my I is going to be here first, right? And I'm going to check for X if the next one, the contiguous one, next one is not X, which means it's Y or Z. It can be anything. Well, I plus 1 is not equal to I. Now I need to check the third one, which is I plus 2. So the I plus 2 is not equal to I, and I plus 2 is also not equal to I plus 1. I don't want X to be equal to Y. I don't want Y to be equal to Z. And I also don't want X to be equal to Z. I want all of these three to be different. So I've checked X for Y, I've checked Y for Z, and I need to check Z for X now. So is Z and X equal to each other? No. So I is not equal to I plus 2, which makes it a valid window. Once I've checked the valid window, right, now my iterator, the I, will move forward. Now, since I had I right here, now my I will move right here. And now I'm going to calculate from Y, right? I'm going to start my window from here, which means I'll check Y for Z. Are these two equal? No. Then I'll check Z for Z. They're equal to each other. Well, my condition is invalid now. I got to move on. So what I'm going to do is instead of checking I plus 2 and I, I'm going to continue my search. In which case, since I had expanded my search to YZZ, now I will include one element in the window and subtract and remove another element, which means I'll remove Y here, I'll include A here. So now my window will be basically ZZA, all right? Again, apply the same conditions. If it does not work, move on. ZZA. So this is how the sliding window works. I'm going to implement it here, and I hope it makes sense. It is a little complicated, but the basic idea of sliding window is that you fix a length or you don't fix a length. But basically, you have a window in which you set conditions and you look for patterns. If the pattern matches, well, voila, you have found your answer. And if the pattern does not match, you keep moving. That's exactly what we're going to do here. So as you can see here, we have an S as an input, the string, and we want to write the code so that any kind of string given, the algorithm will work for. So what we're going to do here is, first of all, I need to count, return a count of elements, a count of the substrings that are good substrings, right? So I'm going to initialize it to 0. Then since the length of my window has to be 3, as you can see here, so k is equal to 3. Let's say I call it length, right? To make it simpler. And now what I'm going to do is I'm going to define a window to be slide. So I'm going to say window is equal to I, which will be the first element, and then two indices later, two indices after the I. So at first iteration, I is 0. So I plus 3 will take me to the second index. Let me explain it to you. So I right here, let's say if I have an array, or let's say if I have a string, right? S, A, N, D, right? This is my string. And my iterator I is right here, which means it's at 0 index. Now, what will be at the third index? It will be 0 plus 1 and 0 plus 1, right? 1, 2. So what I will do is I'll add I, which is equal to 0. So I plus 1 is equal to 1, right? And then I will do, since I is equal to 1, I'll add another 1. So I is equal to 2. So how many operations have been done here? 3. 1, 2, 3. So what I will do is I will do I plus 3 operations, because what we're taking care of in the for loop is the operations. We're not taking care of the actual addition. Actual addition gets taken care of by itself, right? So what we're going to do here, I'm going to put I plus 3, and that will help me create a window. And the window will be out of the string. So I'm going to slice the string S with this window from I to I plus 3. And that's going to be my window, right? So now what I'm going to do is I'm going to write a loop. So the loop, I in range length of S minus 2. Why do I use minus 2 here? I'm using minus 2 here is because my I, if I'm looking for, let's go back to the same example, right? X, Y, Z, Z, A, Z, right? And I'm iterating I. I will check for the first 3, then I will move here, I will move here, I will move here. If I moves any further, our window becomes smaller, our window becomes smaller than 3. We don't want our window to be smaller than 3. I want to stop I here, so this should be the last. So the window will be I plus 3. But if I move my I here, then it means that my I will have only one more element to compare with. The window will become less than 3, and that's what we don't want. So I'm going to keep my I minus 2, which is basically whatever the length of whatever the indices is here, which is 0, 1, 2, 3, 4, 5. So I want to keep minus 2. So 5 out, 4 out, and I want to keep my I at 3. And once my I arrive at 3, I want this algorithm to exit, right? So my window's going to run, and every time if window 0 is not equal to window 1, and window 1 is not equal to window 2, and also I need to check the comparison between window 0 and 2, and window 0 is not equal to window 2, then I'm going to say that I have a good substring. So I'm going to increase the count plus equal to 1. Else, if the condition is not met, I will say continue. Continue. And then I'm going to return the count of the good substring that I found, right? And that should be my answer. Let's find out. Well, I passed the test, and I'm going to submit the code. Of course, it's not super optimized. I think there might be better ways to do it. Beats 38.18%. Well, I don't know. Anyways, Yes, this is our solution. I hope you were able to understand this. If you have any questions, you can ask in the group. You can also comment, write your question in the comment section. But just to reiterate and give you an overview of what a sliding window is, a review to understand, to recall what we've learned so far, is a sliding window pattern is an algorithm used to look for patterns, patterns that can be used on like a linear function or a linear data structure. If you were looking for a pattern, for example, to just look at it conceptually, let's say you have a large wall, and on this large wall, there are Chinese characters, right? I don't know how to write Chinese, but these are how the symbols can be. For example, this was Chinese or anything like that, or Japanese, some language that does not exist. For me, Chinese is very difficult, right? So let's say if you were to look for specific patterns, if you were to look for something like this, right? Either you could go in linear fashion, but what if you wanted to linear fashion and check each and every one until you arrive at this one? But what if you wanted to find out how many of these are actually in there, right? For that, you will need, and if there are like thousands of them, and you wanted to just look for these, you didn't want to care for anything else, you could use a sliding window. You could expand your search window until you hit a condition where it does not make sense that it can be found. Well, I think it's going to get more complicated from here. I think the more you implement sliding window, the better you can understand this. But the idea is that you slide your window across the array or the string, a linear data structure to find out what you're looking for. That's one of doing things. There are other ways, there are other algorithms that are more efficient you can use. And this was a fun concept. I try my best to explain to you. If you guys got it, great. If you guys did not get it, just ask some questions. Thank you very much for watching. And I'll come back with another video on, let's say, hash maps and recursion. That's a very important topic for everyone to understand. People want to understand the binary trees and linked lists. Recursion is absolutely essential for production level code and for other purposes. Thank you all for watching, and I'll see you soon. Assalamu alaikum wa rahmatullahi wa barakatuh.